Today we're going to be talking about solving logarithm equations. And this is an important lesson because we end up solving logarithm equations throughout the next few sections. This section is the most basic of all of them, where if the bases of the logs are the same, so you have a log base 5 of x on one side, and say you have that equals log base 5 of 487, set the insides equal. I call x and the 487 the insides. There is one log function. If there is one log function combined into one log and write as an exponential. Okay, so meaning if we have log base 2 of x equals 7, how you break that x out is we write as an exponential. 2 to the 7th equals x. Now check for extraneous solutions, meaning the inside, this x can't be less than or equal to 0, so it can't be negative. Okay? Then that came out of our graphs. Remember our domain, we start with x as being greater than 0. So the inside, those x's can't be negative or can't be equal to 0. So our first example. Notice how we have one logarithm equal to a number. So how do I break this 2x minus 1 out of the logarithm? We write it as an exponential. 6 to the negative 1 equaled 2x minus 1. That's why learning that conversion was so important. So I have 1/6 is equal to 2x minus 1. I add 1. That's 7/6 is equal to 2x. We divide by 2 or multiply by 1/2. 7 over 12 is equal to x. And then when I plug in 7 over 12 here, we don't get 0, so this is a valid solution. Okay, solving logarithmic equations. Since we have the logarithm equal to 8, 5 to the 8 is equal to x to the 4th. Okay, now we take both sides to the 1/4 power. So we get 5 squared is equal to x. That is going to be equal to 25. So x equals 25 in this case. And when I plug in 25 there for x, we're going to get a positive number, so we don't have to worry about extraneous solutions. I'll give you a hint. When you have something with a squared, that's when we might have some extraneous solutions. Okay, so since I have a log on one side, a log on the other side, the bases are the same, so I can set x squared equal to negative 6x minus 8. Now, try and get one side to 0 and factor. So, two things that multiply to be 8, positive 4, positive 2, those are going to be add to be 6. So we get our possibilities of negative 4 and negative 2. Now again, you need to check these. These could be extraneous solutions. So I plug into my equation. So I have negative 4 squared equals log of negative 6 times a negative 4 minus an 8. So on this left side, we get log base 4 of 16. And on the right side, we get log base 4 of 16. So when I simplified, I didn't get a negative, so that's a solution. Now let's test the other one, negative 2. And again, you just want to make sure the inside piece doesn't become negative. So in this case, we get log base 4 of 4, log base 4 of 4. So that one also works. We had no extraneous solutions. Those are both our solutions to our equation. Next one. Again, since your log bases are the same, I can set x plus 4 equal to 3x. So I subtracted x over to get 2x, and I get x equal to 2. And just doing a little bit of mental math, you can plug in 2 and get a positive number, plug in 2, get a positive number. Those are both the same thing. So x equals 2. Now for inequalities, if your base is bigger than 1 and your x is greater than 0, what we can do is we can then say, we can essentially convert it to an exponential. Okay? If you're greater than, you could set, so like our first example, we can set that x is greater than 3 to the 6th power, x is greater than 729. Now for less than, you have to keep in mind your domain restriction of 0. So what I do is I set my x in between 0 and 2 to the 4th. And 2 to the 4th is 16. So that's our answer for that one. Okay, the next one. Now, if we have, so if you are looking at a log and you have the same base on both sides, you can just deal with the inside pieces. So since I'm greater than here, 2x plus 8 greater than x plus 5, if I subtract the x over, I get x greater than, I subtract the 8 over, negative 3. That's our answer. So what you can kind of do is you can almost essentially ignore the logarithm pieces. Okay, and I had the answer sitting here for us. I think I made that as a little note to myself just to make sure we were doing it correct. In this next example, we have to solve this inequality. So just as before, we're going to set 2x plus 1 less than or equal to x plus 4. I'm going to subtract the x over to get x. I'm going to subtract the 1 over to get x is less than or equal to 3. Now, the key piece that you need to understand here is x is less than or equal to 3. That includes all negative numbers. But as we know, this inside piece of this logarithm can't be negative. So what we need to do is we need to look at our restrictions on 2x plus 1. That has to be greater than 0. So x has to be greater than negative 1/2. We also have to look at that x plus 4. X plus 4 has to be greater than 0. Or x has to be greater than negative 4. So I know x has to be less than or equal to 3. Now I need to decide between these two. Okay? So pick a number in between negative 1/2 and negative 4. Say negative 3. And see if negative 3 makes either one of these inside pieces negative. If I plug in negative 3 here, we do get a positive number. But when I plug in negative 3 here, we get negative 6 plus 1 and negative 5. So a number between negative 4 and negative 1/2 wouldn't work. So we need to choose the bigger of the numbers. X has to be greater than negative 1/2 and less than or equal to 3. Guys, there are your lesson questions. Please make sure you do all of those questions and your answers are submitted on time. Guys, there are your lesson questions. Please make sure you do all of those questions and your answers are submitted on time.